Assalamualaikum and a very good evening to Mr. Arif and Mr. Ifan. My name is Muhammad Azari and I am representative from company ASR. Today, I want to have a discussion between you two, which I want you two to determine the best material used for making the airplane fuselage. But first, I will explain about the airplane. Airplane is a transportation vehicle which are designed to move people and cargo from one place to another. Airplanes come in many different shapes and sizes depending on the mission of the aircraft. The airplane shown on this slide is a turbine power airline. Okay. As you can see here, the fuselage or the body of airplane is a hollow tube which hold all the pieces of airplane together. The fuselage is a hollow because to reduce the weight. As with the other part of the airplane, the shape of the fuselage normally determined by the mission of the aircraft. For example, a supersonic fighter plane has a very slender and streamlined fuselage to reduce the drag associated with high-speed flight, while the airliner has a wide fuselage to carry the maximum number of passengers. And on an airliner, the pilot sits in the cockpit at the front of the fuselage, while passengers and cargo are carried in the rear of the fuselage. The weight of an aircraft is distributed all along the aircraft. The fuselage, along with the passenger and cargo, contribute significant portion of the weight of an aircraft. The center of gravity of the aircraft is the average location of the weight and is usually located inside the fuselage. In flight, the aircraft rotates around the center of gravity because of torque generated by the elevator, rudder and aileron. The fuselage must be designed with enough strength to withstand this torque. As you can see here, this is 2D and the cross-section of the airplane fuselage. Okay, let's go to our main event, which is our company Asia wants engineers to determine the best material used for building the airplane fuselage. This is because recent years, many airplane fuselage are damaged by many unknown forces such as deterioration. As a result, huge amount of money needed to be used for repairing the airplane before taking a flight. Choose the material that can make consistency occur. So, you are given model which you need to determine the best material used for determining the maximum allowable torque that can sustain by the fuselage. So for the question, the main dimension of the cross-section of an airplane fuselage are shown below. As you can see there, the local shear stress of 125 MPa and the angle of twist per meter length of fuselage is not allowed to exceed 0.00333 radian per meter. Determine the maximum allowable torque that can be sustained by the fuselage. And also, the thickness of the wall is T equal to 6 mm. This is a model only. So, can you give me your point of view?
Thank you, Mr. Dayak, for the explanation. Before I continue, let me introduce myself. My name is Muhammad Arif Ifan bin Azhar. For this discussion, in my opinion, I think the best material that we can use for airplane fuselage is 2014 T6 aluminum alloy. Why I think this aluminum alloy is the best one? Before we go to the part, let's learn a little bit about this aluminum alloy. This aluminum alloy is in the T6 temper. It is also often used in the aerospace industry. This is because this aluminum alloy is easily machined in certain tempers and among the strongest available aluminum alloys. As we know, this type of aluminum alloy, 2014, is the second most popular of the 2000 series aluminum alloys after 2024 aluminum alloys. Next, we go to the part why I think this material is the best one. There are many properties we can see. For example, weight, strength, linear expansion, machining, malleability, conductivity, joining, reflectivity, corrosion resistance, toxicity, and lastly, recyclability. The first point is weight. This aluminum alloy have lightweight with a specific density, 2,790 kg per meter cube. This lightweight can reduce dead weight, reduce energy consumption while increasing load capacity, and also it can reduce noise and improve comfort levels. Second point is strength. This aluminum alloy does not become brittle at low temperature. It also have strength increases at low temperature, while at high temperature, the aluminum strength decreases. We can see that high strength is sufficient for airplane fuselage. Third point is linear expansion. This aluminum alloy has large coefficient of linear expansion, which is good, very good benefits. The size of aluminum changes very little per increase in temperature. It also have coefficient of thermal expansion, which is 23 10 power up negative 6 per Celsius. Next, malleability. Easy to form any operation. This aluminum alloy very beneficial in the rolling of strip and foils, as well as in bending and other forming operation. After that, joining. This aluminum alloy have feeder facilitating easy jointing are often incorporated into profile design. For example, fusion welding, friction, steel welding, bonding, taping, and are also used for joining. Next point is reflectivity. This aluminum alloy have a good reflector of both visible light and radiated heat. For corrosion resistant, this aluminum react with oxygen and then form an extremely thin layer of aluminum oxide. It is provide excellent corrosion protection. This layer is also self-repairing if damaged. For the solution of our example is, okay, this is the fuselage. As we know, the modulus of rigidity of 2014 T6 aluminium is 27 Pascal, gigapascal. Then the shear stress is 125 megapascal. Then the angle twist not allowed to exceed 0.0033 rad per meter. Then we can, and then after do the calculation, we get the answer. I get the answer. The maximum allowable torque is 6.392 10 power up 6 Newton per meter. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to Mr. Hidayat and Mr. Arif. Okay, first of all, thank you, Mr. Hidayat, for the question from your company. So, for the question, I'm going to present the usage of the titanium alloy TI6AL4V for airplane fuselage. Before we continue, my name is Muhammad Irfan bin Ismail. I am a representative from the Research and Development Department. So titanium, a little bit of background of titanium. Titanium is a silvery gray metal. In predictable, it is found on ore. Human had known titanium for almost 220 years. It is the fourth most abundant structural metal in the earth crust after aluminium, iron, and magnesium. So the problem regarding the differentiation of titanium is never an issue. Titanium is found particularly in all rock, sand, clay, and other soil. It also present in plants, animals, natural water, and deep sea. Also can be found in meteorites as well as stars. So titanium alloy TI6AL4V is alloyed with 6% of aluminium and 4% of vanadium. So why we suggest the usage of titanium TI6AL4V alloy? It was never a new discovery. It has used by military aspect for many years, but this time want to propose it to be used in domestic aspect. First of all, titanium alloy has high strength to weight ratio. Obviously compared to any other metal, actually it has the highest strength to weight ratio. It can withstand up to 1,200 megapascal. It has good fatigue strength and fracture toughness, meaning it will have way more flight hour compared to your usual aircraft, less reparation and less services. It can withstand high and low temperature because it has high boiling and melting point. It will not have any problem to fly from sub-zero temperature until 800 degrees Celsius. It is corrosion resistant. Generally resistant to all type of corrosion, either acid, alkali, organic solvent, seawater, rain, or even atmospheric pressure. We can say that an aircraft with titanium alloy is ready to approach any unplanned and unpredictable situation. It has low density, meaning that it is quite light compared to other metals that have the same mechanical and thermal properties. This is a little bit calculation based on your question, based on your situation. After we done our calculation, we can know that the maximum torque that the fuselage with titanium alloy I6AL4V is 104 10 to the power of 6 Newton meter. Okay. Moving on to the challenges in using the titanium alloy in domestic aircraft. First of all, high cost of extraction. It is abundant, but to extract it from the earth and to process it need a very high cost. Moving on, it is heavier than aluminium, but actually because of it has higher strength to weight ratio, we only need less titanium compared to amount of aluminum used for your normal fuselage. And titanium is hard to work with. Titanium is has high malleability, but because it is quite strong, it has low machinability. So these three are the challenges that we must tackle before we use or we implement a titanium alloy in domestic usage. But obviously, I believe this type of challenges is nothing new, and we can tackle it due to our uh, due to the time, due to the moving of technology, and how obviously many companies, aircraft companies out there are actually looking toward titanium alloy as their replacement for normal domestic aircraft. So, yep, that's all for me. Thank you.
After I have discussed with my upper management in the company of Asia, we conclude that the company choose the aluminum alloy aluminum 2014 T6 for being used for making the airplane fuselage. Yay! Please give applause to Mr. Arif. Okay, there are many reasons why we choose the aluminum alloy compared to titanium alloy. Okay, firstly, the strength or weight of aluminum alloy is lighter compared to titanium alloy. Next, the aluminum alloy are more cost effective compared to titanium alloy for machining and welding. Furthermore, corrosion resistance for aluminum is better comparison with the titanium alloy. And lastly, the allowable torque for aluminum alloy is more than titanium, which is proof that aluminum alloy can last longer and more powerful when building the airplane fuselage. Okay, that's all from me. Thank you.